Welcome to another session with the Green World Group. This is Fasih Ahmed, and today's topic is hydrogen sulfide, also known as H2S. But there's a lot of other things that we would be discussing in terms of their names. But what is hydrogen sulfide? Well, this is a very common gas, a very deadly gas, toxic, you could say, of the world, where usually found in the oil and gas industry. So one of the most dangerous gases that we are going to talk about is the hydrogen sulfide. So what is hydrogen sulfide? Well, it is highly toxic. In high concentrations, it can kill you within minutes. Would be an over exaggeration. I would tell you it could kill you within seconds. I personally have a lot of experience with the oil and gas industry, worked there many years, and biggest enemy to mankind is hydrogen sulfide in these aspects. What we refer to hydrogen sulfide as H2S. Well, H2S is its compound formula. Two hydrogens, one sulfur, right, is H2S. But in the world, we have given a lot of names for hydrogen sulfide, mainly because we need to associate its properties to it. So I'm just going to go over a few common ones that the world recognizes H2S with, just for its understanding in terms of its properties, which we will talk about in a lot of detail in this short webinar. So a few things I want to name out here. This gas is also referred to as the sewer gas because it is found a lot within sewages. It is also referred to as stink damp. Now there's two major properties being discussed here. Something that smells, stink, and something that could be damp. Why? Because it is very highly soluble with any kind of liquid. And I'll explain to you further about that as well. Also known as sour gas, crude oil, sour crude, swamp gas, and most important and the most common is the rotten egg gas, the gas that smells very similar to rotten eggs, right? But let's go in very detail in its properties because we must know what we're up against. So the physical state of H2S is a gas. It's going to be always found in a gas state. The reason why we're always going to be dealing with this in a gas state is because if we want to get it towards some other form, we'll have to take the temperature down to negative 40 degrees to see it in a liquid form. That for human beings, that's not easy for us to survive within negative 40 degrees. We could do it in a controlled environment, but most of the times, not possible. So we will always be dealing with this as a gas, especially in areas where this gas is usually found. Those are hot climate areas, and I speak of the Middle East. So H2S will always be dealt with as a gas, and that poses a lot of problems. Color of this gas, well, it doesn't have any. Just like oxygen, we know it's here, it's all around us, but this gas also doesn't have any visible colors. It's invisible to us, which is a major problem to us too, because we can't see it, right? Let's talk about its odor. Well, in very low concentrations, it will mimic the smell of rotten eggs, but here's the problem. We shouldn't associate this gas to the smell. Why? Because our human nature will kick in by sniffing the air. And what's happening is we're inhaling the gas as much as possible, which is very hazardous to us. So in high concentrations, what happens to the sense of smell? The first thing we lose is our sense of smell because of its stench or because of the strength of the smell of rotten eggs. The mimicking of the rotten eggs, the first thing it will paralyze will be your sense of smell. So we might get a whiff of it, and if the concentration increases, we lose our sense of smell. So we would think, oh, okay, it might have just passed by, but that's not the case. What about its flammability? Well, it is very, very highly flammable. This is also the reason why we enforce workers to wear FRCs, fire-resistant clothing. The reason because, now, nothing is fireproof. Even the clothing that we'll wear is not fireproof. Even fire-resistant clothing is not fireproof. But what it is proof of is static. So it won't create static. So something as small as a static spark is enough to ignite this gas. So be careful about its flammability. Its vapor density, let's talk about its vapor density. This gas is very heavy. It is heavier than oxygen or heavier than air, for which it will always be low riding. It will always stay on the ground. That poses a huge problem for humanity. Why? Because we walk on the ground. We haven't learned to fly yet. Yes, we have created means to fly, but we will still be walking the earth. And this gas will be found on the ground. So it will stay always below air, right? Keep that in mind. That will save you in a lot of incidences. So knowing these properties is very important. Now let's go towards solubility. It is highly soluble in any kind of liquid, but when it mixes with water, it becomes acidic. And that is also a major problem. When it goes into us, what is our blood? Our blood is liquid, right? So that's why it replaces oxygen very quickly. And our blood travels all over our body. It circulates all over our body, right? Which I will explain further on too. So last property, corrosive. This gas is highly corrosive towards metal. This is the major reason why we are constantly doing shutdowns. We're constantly doing maintenance work around oil and gas areas, production plants, process plants. So what happens is, yes, the pipe looks very shiny and bright from the outside, but due to the time and the concentration, which is exposure to that pipe, it might get corroded from within. And what happens to metal when it gets corroded? It weakens, right? So there might be leakage occurring on those pipes. If I were to say, this is the only property that keeps us working and generating money. But if you've realized none of these properties are beneficial to us, except the corroding part because it keeps us working. But none of these properties are enough so that we can identify this gas. We can't see it, there's no color. We can smell it in small concentration, but if the concentration increases, we lose our sense of smell. It is very highly flammable. A small spark is enough to ignite this gas. Also a reason why we prohibit the use of cell phones, signals through those cell phones. Even the flash of a light of a camera is enough in some cases. It's very soluble with water. It's very dense than air. It stays low bound. And it's highly corrosive. None of these properties are enough for us to identify this with our human abilities to identify this gas. So what do? We need proper training. We need direction. We need proper process to understand this, which I will explain throughout this. But more understanding to what this gas really is. There are only two places there's only two types of places where this gas will naturally be released from the earth. One, a volcano would release this gas, and second, a swamp. Yeah. So the algae that forms over on top of a swamp, what happens is it covers up the water, the stale water, right? That has been stale for decades, not been moved. There's no movement in that water. And what happens, bacteria starts to form, right? And when that algae develops over that surface, yes, this gas is now going to be released or created in great amounts. For volcanoes, well, that's the earth releasing it naturally. And a lot of gases will be released as well. But now, coming back to its properties, you might think, okay, the gas is very highly flammable. All right, it might just disperse and go into the atmosphere or get burned. But there's another catch with that, because when this gas is burnt and released into the atmosphere, it turns into a much more hazardous gas, right? Which could create acidic rain. What that gas is, make sure to follow us on Green World Group for more enhanced training, right? So for decades, we were trying to get rid of this gas because we didn't know what to do, or we didn't know how to utilize it, or we can't put it back into the ground. So we were trying to burn it in flare lines, and sadly has created the carbon emission to this world as we know today. So it was creating acidic rains in nearby regions, right? Because when to mix with dark clouds, it would create acidic rain to the neighboring areas. So this is the natural places where H2S is released. But what about places that we already know, the industry? Well, yes, the natural gas processing areas, the petroleum refineries, the oil and gas wells, sewage treatment plants is where you would find this, oil and gas reservoirs, crude processing, but not only just limited to this, the dairy farms, gas emitted from fertilized, sorry, not fertilized, emitted from the manure of cows in high quantities would release a lot of H2S. Not only that, but leather factories would also have a lot of it, right? And many more places that we humans are dealing with, are using it for manufacturing purposes and processing purposes. So how do we measure H2S? Well, we have two means of measurement towards H2S. Because it is a gas, we are going to measure this gas in ppm, parts per million. And the second means of measuring is percentage, right? But percentage is usually not the best way to do it when we are in the case of when we are at ground. But percentage is what companies would use, what major corporations would use. So if a company were to state, in the month of we retained 10%, 20% H2S. To the normal human being, yes, we will read 20% and we'll say, okay, that's not that bad. From 100 to 20%, okay, that's not bad. But in reality, that converts, and if you knew the equation, it converts to 1% being 10,000 ppm, and 20 would mean 200,000 ppm, right? So what is ppm though? We usually calculate, we are calculating gas by parts per million. Parts per million, and that's not just an exact million parts, it's an approximate million. Because gas are particles that are so small that it's not visible to the naked eye, right? So we've calculated through parts per million, right? Which I could explain further on, but it'll take a lot more time. So feel free to join us with the Green World Group for further explanation. So these are two means of understanding how much gas there is around us. What's the concentration that is around us? Or how much there is within the area that we were trying to go into, which would contain H2S. Now, the exposure levels to H2S, the safe exposure, the permissible exposure limits, so you can say. First of all, we need to understand what exposure is. Exposure is calculated through duration and concentration. So how much time we spend and how much there is of it. So 8 hours work, which is permissible exposure limit, all right, one shift, one whole day of shift, is 10 ppm, 10 ppm. So anything from below to 10 ppm is 8 hours. We're allowed 8 hours. Why? Because when we finish our shift after working 8 hours in such a concentration, we go home, we rest, we sleep, and our body will naturally release it, and making us ready for the next day. Right? So we'll come back with H2S released from us. But when we consider areas where there is more than 10 ppm to 15 ppm, we consider that as short-term exposure limit, which is maximum 4 hours of work. Anything beyond that is very hazardous. We might not come back to work the next day, all right, or we'll be late because our body would naturally take longer to release it from us. And then comes the immediately dangerous to life. That is anything beyond 100 ppm. At that stage, you are going to lose something. And the first thing you will lose, will be possibly your sense of smell. Right? So you should absolutely stop. But throughout all plants, throughout all major gas plants, all alarms are raised at 20 ppm, right? Which I'll explain further detail. So what happens to us at the levels of these toxicity? We've done a complete study of this. And from 0.13 ppm, well, preferably from 0.1 ppm, would immediately be able to smell this gas, right, in the minimal odor of it. But usually we'll smell it when we're lower, closer to the ground, maybe working low, because at that level of concentration, the H2S gas is at our feet, at our shoes, right? So if we're working very close to the ground, maybe the wind blows and we can probably get a sniff of it, of the rotten egg, the mimicking of the rotten egg gas of that smell. Now, from 5 ppm, yes, it's easily detectable in terms of its odor, right? And then from 10 to 15 ppm, which I've already stated, it's considered as short-term exposure limit. But you get the first sign, which is irritation to your eyes. But if you're working in the oil and gas industry, you might not get that. Why? Because of our own PPE. If you're wearing safety glasses or safety goggles, you won't get that irritation. Then from 25 ppm, what happens is that you get a very strong smell of those rotten eggs, but yet tolerable. Here's the thing. We sound the alarm at 20, not at 25, even though we're not facing any serious repercussions here, but we're still sounding the alarm at 20, not at 25. The reason to that is very simple, because we want to avoid people from panicking and running, right? Again, these are two major things that in safety we would always try to avoid: people from acting, panic, and run. So we sound the alarm at 20 to give people the grace period, to give people the peace of mind to react, to remember their training, to be calm, right? And evacuate accordingly. And I will tell you about how to evacuate. Now, from 100 ppm, this is immediately dangerous to life and health. So what happens here is that you start to cough because your body is giving you the indication that it's losing oxygen, or it's throwing out the oxygen and replacing it with H2S, right? And you lose your sense of smell within 2 minutes. It's gone, right? From 200 to 300 ppm, within an hour, you start to get this itch within your lungs. There's irritation, an itch you cannot scratch because it's internal, right? And that's now, it's affecting your lungs. It's replaced the oxygen. From 500 to 700 ppm, you go unconscious and could possibly die within 30 minutes, right? Then from 700 to 1,000 ppm, you rapidly go unconscious and you can die within less than a minute. And above 1,000 ppm, well, you don't go unconscious, you immediately die, right? Now, how does this go into our body? Well, it goes through the means of inhalation. It enters your body through your inhalation, goes into your lungs. Then your lungs does what it does with oxygen, pushes it into your bloodstream. But here it removes the oxygen, pushes the H2S into your bloodstream, and it is very highly soluble, so it goes further. Then our blood travels through our body and goes to your brain. And as soon as it enters your brain, it switches your brain off. And once your brain stops, what happens to your physical body? Your physical body drops to the floor, where it is now suffocated or engulfed in H2S, and there it is. So how do we protect ourselves from something we cannot see, something we cannot feel, we cannot hold, we cannot even burn, Again, if you burn H2S, there's a very different flame that comes off it, which is blue in color. Right? And so that's why sometimes when you see it in flare lines far away in the distance in the day, you would not be able to see the flame. You could only see smoke or being released, because blue is a color that is usually not visible due to the background color of the sky and so on. But how do we protect ourselves? How do we protect ourselves from H2S? Well, we create signs, we create awareness, we create safety signs, we provide people with wind socks to understand the direction of the wind, to understand where to go, how to go, in what direction we should go. Right? We create safe points, we create assembly points, muster points, if you can say. We create H2S alarms, we have detectors, right? Because our physical ability is not able to detect it. We have breathing apparatuses like SCBA, SABAs, or EEBAs. These are self-contained breathing apparatuses. These are emergency escape breathing apparatuses. And these are self-supplied breathing apparatuses, sorry, SABAs. Right, and then we have training and communication, which is what we're trying to do here right now, which is the most important thing, because we need to maintain adequate training. We need to bring people back for refresher trainings and provide this with communication, two-way street. So very, very important. Let's go into more detail about this. So we have signs, we have warning signs, we've color coded them. Every color represents reasoning, right? Through how much ppm we have or the severity of it. We have images. We usually associate the cross, the skull and bones to, oh, danger, but that's not true. You're lying to yourselves. That sign indicates death, right? Do not sell it short. That sign means death, right? Here's another thing. So you would see signs that would say H2S may be present. Okay, immediately you take the best out of it and saying, oh, okay, maybe, may not be. No, it's there. They're not idiots for saying, oh, it may be present. No, it's there. What they're really talking about is the color. You must pay attention to the color. The color is yellow. Yellow means 10 to 15 ppm, which means it could be this or it could be more. So keep that in consideration. That is important to understand. Wind socks. Wind socks gives you the direction of the wind. These wind socks are usually at a very high area, the high location, so that everybody from far distance can see it. It's usually in the color orange because color orange is something that you can spot from a far distance. It is also law, so that we have a clear understanding which direction the wind is blowing. Again, if the wind is blowing in a certain direction, you must go against the wind. All right, so go against the wind, never go downwind, never go downwind. Why? Because you'll be traveling with the gas. So always go in the direction of the wind. Sorry, in the opposite direction of the wind, right? Now, what if there's no wind? What do you do? Well, to answer that, take our full course, right? But till then, ponder upon that thought. Remember its properties, because the answer is understanding its properties. Let's go forward. Where do we go? Where do we assemble? Well, we must assemble in the briefing area, which is usually the assembly area, the muster point. In the oil and gas industry, especially in on-site and offshore facilities, we have something called the T-card system. The T-card system is very simple and very brilliant. Why? Because before you enter, you place your name on the board. Now, when the alarm happens or when the evacuation occurs and you exit and you get to the assembly point, you must go to the T-card system and either remove your name or flip it backside. What that indicates is that you are safe because you physically removed your name or you flipped your name around, which indicates that you did it yourself and you are safe. But those who weren't fortunate enough to do that would give us the understanding that this person is still in there and he needs to be rescued. Very simple. These are assembly points. You can see there's offshore facilities where you'd assemble. Usually the U-boats will be there so that you can easy means of escape, safe means of escape at sea. We can't just jump into the water. Why? Because remember its property, it's very, very soluble in water and turns into acid. So if it's not engulfed in flame, then the acid will burn you, right? So the U-boats, very safe alternate. Now let's talk about these color codes. Three major colors, very universal colors. We know them. Why? Because we're dealing with them on a daily basis on traffic on signals. We know what they mean, and the same thing represents here, but here also gives you the sense of level of PPE, level of parts per million. So in green zones, there usually is any H2S around 0 to 10 ppm, which is considered safe in terms of one whole day of work, right? Then any area that is marked yellow is 10 to 15 ppm, meaning short-term exposure here, which is maximum of 4 hours of work, right? You would see flashing indications. You would see probably lights flashing, but no alarms. Then comes the red zone. The red zone is considered anything beyond 20 ppm, which is stop work and evacuate. Look at the wind direction and evacuate and get to the assembly point. Right? Keep these in consideration. These colors are not just colors. These colors represent a whole lot of meaning, all right, for safety. Now, I will not present you with the sound of alarm. Why? Because every facility has its own. Please do pay attention in the orientation before you arrive to the facility. Either let it be offshore, let it be onshore. Do be attentive of their alarm systems or their sounds of alarms, because every facility will have many different ones. And they will be using appropriate ones to that facility itself. So keep that in consideration. Now, do you have, what do we have to detect H2S in our workplace? Well, we have three types of detectors. We have a personal H2S monitor, we have portable H2S monitors, and we have fixed H2S monitors. Let's talk about the personal H2S monitor. This is a monitor that is on you. You should place it on your belt area. Why? Because you would have time to react. Again, it is heavier than oxygen, so it will always build up from the ground up. So if you place it somewhere on your chest, saying that, oh, I wouldn't see the flashing or hear the alarm or see its concentration, well, your belt is a safer area. The reason why I'm not telling you to put it on your chest area is because this is your area of inhalation. Our noses are designed such a way that we intake air from our chest area. So by the time the alarm goes off, it's too late. You've already inhaled the H2S. You don't have time to react. However, these H2S monitors will indicate you if the concentration has gone beyond limit by flashing lights, top areas, by making a loud noise in alarm form, and it will also vibrate like a phone. So there are three ways of you identifying how much concentration is around you. Then comes the portable H2S gas monitors. The portable H2S gas monitors are excellent in terms of detecting atmospheres within an area that you would want to go to, especially preferred in confined spaces. But keep in mind, when you use this, make sure you do the gas testing in all three levels, top, mid, and low, right? That is adequately done through gas testing properly, right? Then comes the fixed H2S monitors. These fixed H2S monitors are great in terms of identifying leaks in areas, possible areas that could have leak, where you don't have to have an individual stand there and constantly monitor that atmosphere. Well, we place a fixed H2S monitor, which will report directly back to the servers or the alarm. So if anything, if it catches a leak, it will immediately sound the alarm throughout the plant and indicate exactly where it's happening. So how do we escape? How do we respond to H2S? How do we save ourselves? Now, before I get into this, most of the times, actually all the time, in terms of safety, we tell you to react towards going towards the victim. Here in H2S, we do things differently, and for very good reason. When we see an individual collapse, where there are possible chances of H2S, where we see an individual ahead of us go unconscious and collapse, we tell you not to go towards him. That doesn't mean you run away. No, we tell you not to go towards him because you yourself will also be a victim. So we tell you to immediately call for help, run the other way, sound the alarm, make the appropriate report, not a report, but call for help. And if you are further trained, then you should don the SCBA and immediately go in for the rescue and try pulling him out of that area if you are trained, right? So those are your major steps. Your first step is to sound the alarm. Why? Because if you also go in there, nobody knows, because you've now also gone unconscious, right? This is a gas that is not visible to us in all of its properties, right? So first thing is evacuate. Evacuate, go to safe area immediately. Move upwind if released, right? Go crosswind also. You have two major directions that you can follow, excuse me. You can go upwind and you can go crosswind, but never go downwind. But if not possible, and you can't understand where the wind is, take high ground, right? You don't need to be on the ground. Climb something. All right, then call for help, sound the alarm, raise the alarm, right? Radio it in. Follow means of communication. Assess, get to the assembly point, do the head count, who's there, who's not, consider the hazards, right? If you are going in for the rescue, then put on your breathing apparatus first, get your supplied air of oxygen, and get to the area to perform rescues. Right? Rescue the victim, okay, bring him to the assembly point, bring him to the safe area where everybody is, where the ambulance will also arrive, where the fire department will arrive also. All right, and try reviving that individual with CPR, and leave it to the professionals if possible, right? And provide medical aid accordingly. So what is the SCBA? What are our breathing apparatuses that we can use? Because we would need supplied air to keep us breathing, right? So we have self-contained breathing apparatuses, SCBA, which the rescuers would use. We have supplied air breathing apparatuses, which is contained in high quantities, in greater quantities than self-contained breathing apparatuses, would either be creating it or will be supplying a lot of people from that. And then we have emergency escape breathing apparatuses, which is only for one simple purpose, for you to escape. You don't have time to save anyone. You can't perform rescues on that. You could only save yourself because it's smaller in size. It only allows you to have 15 minutes of oxygen. So here is the self-contained breathing apparatus, which is really good for performing rescues and going into the line of danger and pulling people out, right? Which usually rescuers would use. Then we have emergency breathing apparatus, which I've already explained to you. It has only 15 minutes of oxygen, allows you to do only one thing: save yourself, get yourself to safety, right? And then airline breathing apparatus, also known as supplied air breathing apparatuses, which are tanks of oxygen. Now, how much oxygen is there depends on how many people and how big your tank is, right? But it is longer than at least an hour. Rescuing procedures, how will we provide rescue? How should we provide rescue, right? So obviously these facilities, onshore, offshore facilities, these are in remote locations, and in order for us to get there as quickly as possible, yes, we might use the aid of helicopters. And if that happens, maybe sometimes the helicopter wouldn't land because of the severity or the emergency of that moment. So we'll just drop down the stretcher, right, with the medical help. Now, if we are to take victims out in terms of rescuing them, always remember, go with a buddy system. You apply the buddy system. The rescuers must be at least 2 people, right? More better, yes. But 2 people really helps. Why? Because each of them can watch each other's back, but it also helps in saving the victim out. Follow this process. I can explain this in much more detail if you guys do decide to take the course with us at Green World, right? The release of H2S, know your escape routes, know the alarms, what alarm is for what, so that you are gonna prepare yourself accordingly. Where the breathing apparatus is, use that protection. Check the wind direction, know which direction you can go, which is upwind or crosswind, to get to where? To get to the assembly point as quickly as possible. All right, and remember that oxygen is lighter than H2S, and H2S will always be below oxygen. All right, so your oxygen level should be high ground. Exposures may be a matter of life and death. Right? Know how much H2S is around you. Realize the safe exposure limits. Understand those, and proceed accordingly. Again, guys, this is one of the most dangerous gas known to man. It can kill us within seconds if the concentration reaches a very dangerous amount. Even if you do get out when exposed to 100 ppm of H2S, you might lose your sense of smell forever. So please be careful. And for more information, please contact us at Green World Group, and we'll be happy to share information as much as possible. This is Fasih Ahmed signing off from Green World, and thank you very much. Take care.